Okay, good morning. And I just wanted to make a note of an integral that people have been asking me about regularly. So really, there's a similar integral to the one you see on screen in the workshop 2, well, part 1G. And okay, so what we have here is we have an integral of an exponential function times a sine function. Okay, the one in the workshop is slightly more complicated than this, but I just want to show you the simplest case, and you should be able to figure out the slightly more complicated one. Okay, and a lot of people have observed that, well, to solve this problem, we need to use integration by parts, right? And, well, this is something from first year calculus. But I would just say that I never personally memorize the integration by parts formula. I always just derive it because I just find that easier. Okay, and the way I derive it is, well, I remember the product rule of differentiation. So let's just write down the product rule of differentiation. So if I have two functions u and v, and I differentiate those two, okay, I know that I'm going to have to use the product rule here. Okay, so firstly I'll write this is equal to differentiate u and keep v constant. So u prime v, and because we're dealing with the product rule here, we're going to add u times v prime. Okay, so this is the product rule from differentiation. I hope that everybody can remember this. Um, okay, and what I'm going to do now is I'm just going to rearrange this equation for this term here. Okay, so I'll do that. Okay, so now I've rearranged for that term in the middle. And what I will do now is I'm going to integrate both sides of that equation. Well, hang on, this should be dx, so let me fix it up. Okay, well, I'm just assuming the integration variable here is x. It could be t, it could be anything. Okay, and then what I should note is that this term in the middle here, well, I'm differentiating something and then I'm integrating again. So if as we know, the differentiation and integration are sort of inverse of each other. So if I differentiate uv and then I integrate it, I'm just going to get uv back. Okay, so I can write this equation like so. Okay, and so this is actually the integration by parts formula here. So just maybe it's useful to you, maybe it's not. But the point is that I personally never remember the integration by parts formula. I only ever derive it from the product rule. So maybe that helps you. But anyway, let's use this integration by parts formula for this problem we're dealing with here. Okay, so integration by parts. The integral on the left-hand side is u prime multiplied by v. So if I write out some of these functions here, v prime. Okay, so my integral of u prime v, well, I need to choose one of these, e to the x or sine x, to be my u prime, and one of them to be my v. Okay, so it actually turns out that in this particular case, it doesn't matter which order we choose it. So what I'm going to choose is u prime is equal to e to the x, and v is equal to sine x. Okay. Okay, so I've done that now. So now the integral of u prime times v is the integral of e to the x sine x, right? That's exactly what we're looking for. So let's calculate u. So u is just found by integrating u prime. So integrate e to the x. It's just e to the x. And v prime is found by differentiating v. So if we take sine and we differentiate it, we get cosine of x. Okay, and so now we can use our integration by parts formula to write down the integral of e to the x sine of x. Okay, so this integral is equal to u times v. So u times v is e to the x times sine x minus the integral of u times v prime. So u is e to the x, v prime is cosine x dx. Right. Okay, good. So at this stage you may think, well, I had the integral of e to the x times sine x, and now I've got the integral of e to the x times cosine x, so it doesn't really feel like you've made too much progress here, but well, let's just apply integration by parts to that integral as well and see what happens. Okay, so we're looking at the integral of e to the x cosine of x dx. Okay, well again let's set well, which way here? Let's set u prime. Let's set u prime equal to e to the x again, so that if we integrate e to the x, we get e to the x. Let's set v equal to cosine of x, and then v prime is the differentiate cosine, we get minus sine of x. Okay, and then we're just going to apply the integration by parts formula to this thing here, to this integral. Okay, so we're going to get u times v, so e to the x times cosine x minus the integral of u times v prime, so u is e to the x, v prime is minus sine of x, so I'm going to take the minus sign out and put that as plus, so plus sine of x dx. Okay, now you should be getting really worried, because you should say, okay, well, I started off with the integral of e to the x sine of x, and now I've got it back here, so am I going in circles here? But actually, you're doing well, because I'll show you why. So this equation here, I'm just going to rewrite this equation, but the last term here, which I did highlight in yellow here, this last term, I'm going to, instead of writing that integral, I'm going to write this relationship we came up with by integration by parts. So let's do that. So the integral of e to the x sine of x dx is equal to, well, here we had e to the x, here we had e to the x sine x, and then we were taking away, we were subtracting this integral e to the x, integral of e to the x cosine x, so we're going to take away or subtract that integral, but that integral we worked out was this thing here, so we take away e to the x cosine x, and then we also take away the integral of e to the x sine of x dx. Okay, so now we've got some expression here for the integral of e to the x sine x, and as you can see, we've got this term e to the x, the integral of e to the x sine x on both sides of the equation. So what I'm going to do is I'm going to take this one on the right hand side rather, and I'm going to add that to both sides so that I get all the integral of e to the x sine x terms on the left hand side. Okay, so if I do that, then I get 2 of these on the left hand side, right? So I get 2 times the integral of e to the x sine x dx is equal to, well, I'm just going to bring out the common factor of e to the x. Okay, and then I'm just simply going to divide through both sides by 2 to get rid of the 2 at the front here. And then I get an expression for e to the x times sine of x dx, e to the x over 2 sine of x minus cosine of x. So, in fact, I have now completely solved this problem, because now I have an expression for the integral of e to the x sine of x, e to the x multiplied by sine of x, which is written on the right-hand side completely in terms of known functions, right? So even though back above, when we first applied integration by parts, we got this integral which e to the x integral of e to the x times cosine x. It looked like, well, we haven't made any progress. And then when we again solved that integral and found we got the integral we started with, we thought, oh wow, we're really in trouble here. But in fact, it turns out that if you rearrange that equation, you get some really nice expression for the original integral that we started with, right? So this is a really common problem. You'll see this pop up from time to time, and hopefully this video helps you to be able to solve that when you see it in the future. It should also help you to solve workshop 1 part G, 1G. And again, if you have any questions, let me know. Thank you.